I want to create a process plan now for the turning of my part. So I've gone ahead and I've created the drawing sheet. I've double checked and triple checked that all the dimensions and required tolerances are shown. So then I'm going to copy it and then I'm going to paste this image into my process sheet. And let's take a look at that. So here's my process sheet. I've given it a name. I've set my part as connecting shaft, that this is operation 10. I'm going to make this on an Okuma 2-axis CNC lathe. I have my drawing reference number. I've told it the stock is the cast alloy steel part. I've pasted my screenshot in so everybody's familiar with it who reads this. And then I've come down here and I said, okay, this is operation 10. So the first thing I'm going to do is operation 10.1. And to decide what operation 10.1 is, I want to look at the part and examine it and ask myself, well, what must be done first? Well, this one's quite straightforward and simple. I need to rough turn these 3 diameters before I can do anything else. So I've gone to our tool supplier, gone to their webpage and got a screenshot of their tool. And I've said for 10.1, I'm going to use the rough turning tool, and that has a number 4 tool nose radius. And depending on where you work, this may or may not be acceptable. Most companies would want you to describe the tool as well as the insert used here. But for the purpose of this course, we're going to keep it simple. So I've just got a rough turning tool and I've got a picture of it. So I've shown the RPM here under the RPM column of 800 revolutions per minute. I have the feed in inches per rev. If this were metric, I would do millimeters per rev. And I have my process where I describe the process. This tool will rough turn these diameters and it'll rough face these lengths. And it'll leave 20 thou on all faces. So that's here, 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 and here. And 40 thou on all diameters, which is also a 20 thou radial cut on these 3 diameters for the finished turn. What I should be considering though, this process plan is for a CNC machine. CNC machines have the ability to speed up and slow down as the diameter changes. And this RPM calculation is really based on the 2-inch diameter and turning everything at that. Well, that doesn't give the best surface finish for these. So what I'm going to do is I'm going to alter this RPM column and I'm going to add /CS for cutting speed. So down here, I don't want to actually tell it the RPM. I want to tell it the cutting speed for this tool and this material. So I'm going to say the cutting speed for this tool and this material is 350. And I now need to designate that it's working in cutting speed and not RPM. So I'm going to add the units of feet per minute here. And I'm going to come down and I'm going to look at the finished turning tool. So this operation 10.2. I've described it. I'm going to use a number 2 tool nose radius. And I want its cutting speed to be a little faster. So I'm going to say this is 400 feet per minute. I'm going to rough turn taking 10 thou per rev, and I'm going to finish turn taking 6 thou per rev, which is about equivalent to a 60 micro-inch finish. And I'm going to describe each operation. So this finish turning tool will finish turning the 3 diameters and the 3 lengths. The last thing I need to do on this simple lathe part is the inch 12 thread. So I'm going to scroll down a bit, and this would be operation 10.3. I've described it. I have a 60-degree single point carbide threading tool. I have my picture. This time, however, I'm doing RPM. So I've calculated out my RPM at 1200. I'm going to add RPM to make it clear. And the feed is 0.0833. Remember, for threading, this feed corresponds to the pitch, which in this case is 1/12. And I have my simple description that I'm cutting the 1-inch 12 thread, that it's 1.25 inches long. When we get to this point, we might want to make our customer aware they will not get 1.25 inch thread. The threading tool has to pull out here. The last 2 to 3 threads will not be full threads, and we might want to help them solve this problem. Do they need full threads there? Does this need to thread so that the mating part touches this face? And if it does, we're going to encourage them to add an undercut here so it can. And there are several options we need to discuss with them, or it may not be important for this part. So here's a very simple, I'm just going to zoom out a bit, 2-axis lathe CNC process sheet sample. In the next video, I'm going to take more time and I'm going to work through how we do op 30 for the mill.